let's say you built an agentic workflow and it is not yet working as well as you wish. And this happens to be all the time, by the way. I'll often build a quick and dirty system and it doesn't do as well as I wish it would. The question is, where do you focus your efforts to make it better? It turns out agentic workflows have many different components, and working on some of the components could be much more fruitful than working on some other components. So your skill at choosing where to focus your efforts makes a huge difference in the speed with which you can make improvements to your system. And I found that one of the biggest predictors for how efficient and how good a team is whether or not they're able to drive a disciplined error analysis process to tell you where to focus your efforts. So this is an important skill. Let's take a look at how to carry out error analysis. In the research agent example, we had carried out an error analysis in the previous video, and we saw that it was often missing key points that a human expert would have made in writing essays on certain topics. So now that you've spotted this problem that is sometimes missing key points, how do you know what to work on? It turns out that of the many different steps in this workflow, almost any of them could have contributed to this problem of missing key points. For example, maybe the first LLM was generating search terms that weren't great, so it was just searching for the wrong things and did not discover the right articles. Or maybe you used a web search engine that just wasn't very good. There are multiple web search engines out there. In fact, there are actually quite a few that I tend to use for my LLM-based applications, and some are better than others. Or maybe web search was just fine, but when we gave the list of web search results to an LLM, maybe it didn't do a good job choosing the best handful to download. Maybe web fetch has fewer problems in this case, assuming you can fetch web pages accurately. But after dumping the web pages in LLM, maybe the LLM is ignoring some of the points in the documents we had fetched. So it turns out that there are teams that will sometimes look at this and go by gut to pick one of these components to work on. And sometimes that works, and sometimes that leads to many months of work with very low progress in the overall performance of the system. So rather than going by gut to decide which of these many components to work on, I think it's much better to carry out an error analysis to better understand each step in the workflow. And in particular, I'll often examine the traces, and that means the intermediate output after each step, in order to understand which component's performance is subpar, meaning, say, much worse than what a human expert would do, because that points to where there may be room for significant improvement. Let's look at an example. If we ask the research agent to write an essay about recent news in black hole science, maybe the outputs search terms like these: search for black hole theories, Einstein, event horizon, telescope radio, and so on. And I would then have a human expert look at these and see, are these reasonable web search terms for writing about recent discoveries in black hole science? And maybe in this case, an expert says these web searches look okay. They're pretty similar to what I would do as a human. Then I look at the outputs of the web search and look at the URLs returned. So web search would return many different web pages, and maybe one web page returns is that an elementary school student claims to crack a 30-year-old black hole mystery from Astro Kid News. And this doesn't look like the most rigorous peer-reviewed article. And maybe examining all of the articles that web search returns causes you to conclude that it's returning too many blog or popular press types of articles and not enough scientific articles to write a research report of the quality that you are looking for. It'd be good to just look through the outputs of the other steps as well. Maybe the finds the best 5 sources you can. You end up with Astro Kid News, Spaceball 2000, Space Fun News, and so on. And it is by looking at these intermediate outputs that you can then try to get a sense of the quality of the output of each of these steps. To introduce some terminology, the overall set of outputs of all of the intermediate steps is often called the trace of a run of this agent. And then some terminology you see in other sources as well is the output of a single step is sometimes called a span. This is terminology from the computer observability literature, where people try to figure out what computers are doing. And in this course, I use the word trace quite a bit. I'll use the word span a little bit less, but you may see both of these terms on the internet. So by reading the traces, you start to get an informal sense of where might be the most problematic components. In order to do this in a more systematic way, it turns out to be useful to focus your attention on the cases that the system is doing poorly on. Maybe I write some essays just fine and the output is completely satisfactory. So I would put those aside and try to come up with a set of examples where, for whatever reason, the final output of your research agent is not quite satisfactory, and just focus on those examples. So this is one of the reasons we call error analysis, because we want to focus on the cases where the system made an error. And we want to go through to figure out which components were most responsible for the error in the research agent output. In order to make this more rigorous, rather than reading and getting an informal sense, you might actually build up a spreadsheet to more explicitly count up where the errors are. And by error, I mean when a step outputs something that performs significantly worse than maybe what a human expert would have given a similar input as that component. So I'll often do this myself in a spreadsheet. So I might build a spreadsheet like this. And so for the first query, I'll look at recent developments in black hole science. And I see that the search results has too many blog posts, popular press articles, not enough scientific papers. And then based on this, it is true that the 5 best sources aren't great, but here I won't say that the 5 best sources did a bad job, because if the inputs to the algorithm for selecting the 5 best sources were all non-rigorous articles, then I can't blame this picking the 5 best sources for not picking better articles, because it did the best it could have, or it did nearly as well as any human might have given the same selection to choose from. And then you might go through this for different prompts. Renting versus buying in Seattle. Maybe it missed a well-known blog, robotics for harvesting fruit. Maybe in this case, we look at it and say, oh, the search terms are too generic and the search results also weren't good, and so on. And then based on this, I would count up in my spreadsheet how often I observe errors in the different components. So in this example, I'm dissatisfied with the search terms 5% of the time, but I'm dissatisfied with the search results 45% of the time. And if I actually see this, I might just take a careful look at the search terms to make sure that the search terms really were okay and that poor choice of search terms were not what led to poor search results. But if I really think the search terms are fine, but the search results are not, then I would take a careful look at the web search engine I'm using and if there are any parameters I can tune to make it bring back more relevant or higher quality results. There's this type of analysis that tells me in this example that maybe I really should focus my attention on fixing the search results and not on the other components of this agentic workflow. So to wrap up this video, I find that it's useful to develop a habit of looking at traces. After you build an agentic workflow, go ahead and look at the intermediate outputs to get a feel for what it's actually doing at every step so that you can better understand if different steps are performing better or worse. And a more systematic error analysis may be done with a spreadsheet can let you gather statistics or count up which component performs poorly most frequently. And so by looking at what components are doing poorly, as well as where I have ideas for efficiently improving different components, then that will let you prioritize what component to work on. So maybe a component is problematic, but I don't have any ideas for improving it. So that would suggest maybe not prioritizing that as high. But if there is a component that is generating a lot of errors, and if I have ideas for how to improve that, then that would be a good reason to prioritize working on that component. And I just want to emphasize that error analysis is a very helpful output for you to decide where to focus your efforts, because in any complex system, there are just so many things you could work on. It's too easy to pick something to work on and work on it for weeks or even months, only to discover later that that did not result in improved performance to your overall system. And so using error analysis to decide where to focus your effort turns out to be incredibly useful for improving your efficiency. In this video, we went over error analysis with the research agent example. But I think error analysis is such an important topic. I want to go over some additional examples with you. So let's go on to the next video where we'll look at more examples of error analysis.